All right, so I want to look at another example with you guys of a proton NMR. So what I want to look at with you guys in this lecture is ethanol. So ethanol, CH3, CH2OH. All right, so I'm going to ask you some questions here. So I want you guys to figure out how many signals on a proton NMR would you expect to see here. If you said 3, you're correct, right? So you're going to have here, if we draw this thing out, take a second and catch up here, right? That's your structure, Lewis structure of ethanol. All right, so let's break this into our 3 little groups. So over here, we have position A, then we'll call this B, and then this last little fellow over here is C. So 3 sets of signals is what we would expect. So let's go through this analysis here, guys, together. So let's first take a look at our H is at position A. So we're going to draw this thing out 3 times. Now, as you guys finish drawing that out, let's put a box around this. Right? And then this, remember, this is your house. Okay? So we look to our neighbors. Right, so we're going to look over here. Well, there's 2 H's there. So N is equal to 2. So N plus 1 is equal to 3. That means we expect to see a triplet there. Now, the integration for this should be 3 because there are 1, 2, 3 H's. Remember, integration tells you what's inside of your house. N plus 1 tells you what your neighbor is. Let's look at B. So again, take a second, draw this thing out. So let's take a look here at this position. So there's your house. All right, so let's do our N plus 1 here. So I know it seems like, well, we definitely have 3 neighbors over here. There's definitely 3 there. The question is, what's happening with this guy? So it turns out that the H's of alcohols, we're not going to count those for splitting. So don't count for N plus 1. And then let's just write here, normally or maybe often is a better word, don't count for N plus 1. The reason why that's the case is because of something called proton exchange. Right? So it turns out that hydrogen is in a solution of ethanol and it's H bonded. Right? So when it H bonds to another molecule, right? Like if you look at it down here. Right, so there's 2 molecules. When that H bond occurs right there, it actually causes that bond right there to kind of not really be there. So, part of the time it's hanging out over on this side, and part of the time it's hanging out over on that side. So because of that, you're in this house, right? Think of it this way. You're in this house, and you look over to this side, and you say, okay, well, look, there's 3 people in that house. I can see them. And then you look over here, and all you hear is the front door slamming of your neighbor's house, and you look in there and there's no one there anymore. The H is gone. There's no proton. All right, so then you look over here again to this side, and okay, there's 3. You hear the door close, and you think, oh, well, maybe he's back. And then you turn over and you look over again quickly, and that H is gone. So the H is being exchanged at a rate that's faster than the NMR can detect. Well, question for you. How can you slow that down? Well, what if you lowered the temperature? So if you lowered the temperature, then that proton exchange slows down. Another thing you can do, what if you diluted the sample so that there wasn't such an opportunity to have that proton exchange? That would work too. Right? But normally, in this class at this level, we just don't count it. So because of that, then your n plus 1 is equal to, right, 4, because n is only equal to 3 here. We're not going to count that H of the OH, guys. So it's of the OH. So that's a quartet, 1 to 3 to 3 to 1. And then our integration for that would be 2, because there's just 2 in the house. And then last one to look at here is what's happening at C. So I'm going to write that out as CH3, CH2, OH here. And because this proton's kind of getting popped on and popped, it's off and on, back and forth, right? It's getting pulled off, getting put on at a rate that's faster for it also to see what's happening in its neighbor's house. Your n for that guy is equal to 0. So it's kind of like it's just a free H by itself. So then what you see is a singlet with an integration equal to 1. Right, so then when you put this spectrum together down below, right, you'd have your x-axis there. There's your 0, chemical shift, C peak for tetramethylsilane. Now, looking back up here, what's going to be the farthest downfield? Well, probably this. Probably C, because it's directly attached to an electronegative element. So probably C, and then B, and then A. They don't always go in order, by the way. So the order is just dependent on the circumstances. So this one, they happen to go in order. So then we expect to see what? A singlet here. So, and then the integration would be 1. Next comes our quartet, right? And that's going to be an integration of 2. So you might see a 2 or a 2H there. And then a splitting of 3 and an integration of 3. So a triplet and a 3H there. So that's what your spectrum would look like for this. And then again, kind of going backwards, if that was your spectrum, let's see if we can do this. And let's say you're given the molecular formula. So CH3, CH2OH is C2, right? H, what is it? 3, 4, 5, 6. Oh. Okay. So if we knew that that was our molecular formula there, and this was our spectrum, well, we could work backwards a little bit with this thing. So here we know that we're a 1H. So that means that we're either a CH or an OH. We don't know, but it means that we just have 1H there, and that's in our house. Right? And then we're next to something that gives us no splitting. So we suspect that maybe that's the alcohol. For this 2, and I'll move this down here below, it means we are a CH2. That's in your house. And the splitting pattern here is a quartet, so that means we're probably next to a CH3. And then that guy there, integration is a 3, so we know that we're probably a CH3. It's a really good guess. With a splitting of 3, which means that we're next to a CH2. So when we put all of those things together, we get CH3, CH2, OH. Right? And again, with NMR, you shouldn't have to guess. So if this is what you think the answer is, you should check your answer, right? So we can do that. So how do you check your answer? Right, well, we expect 3 signals. Are there 3 above? Yes, there are. Okay. Let's do integration, and then n plus 1. So integration would be 3, 2, and 1. So we double check up above. Is that the case? Yeah, 3, 2, and 1. So far, we're looking good. N plus 1 for that first group would be a triplet, right? Because it's 2 plus 1. Integration for that CH2 is going to be a quartet, and the OH is going to be a singlet. So then we look at all of that together, and we see does it fit in together? Well, let's look. Integration of 3, a triplet. There we go. Integration of 2, a quartet. Yep. 1, a singlet. There we go. All evidence points to this being our formula.